right, so let's get started. Today's lesson is on some trigonometry basics. And trig is a notoriously difficult section for students. And the reason why I think it's important for us to focus a little bit on trig is because we cannot get enough marks from analytical geometry and statistics alone. So the way that the exam is set up is that we're going to have to answer some of the trig questions, or at least some of the Euclidean geometry questions, if we want to get a few more marks. So in my opinion, being able to do trig is really, really, really important because it's a big section. So the reason why this is just the trig basics is because this is your first question on trig. So I'm not going to look at the graphs today, which I think is something that a lot of people struggle with. And I'm also not going to look at any 3D trig today, but we will look at those things before you actually do right. So I'm talking about your very first question on trig, which involves most of the time simplifying things to one trigonometric expression, or working with a diagram where you have to use the theorem of Pythagoras, or a ratio in terms of a letter, the general solution, etc., etc. So those are the things that we're gonna focus on today. Yes, Diana, you're quite right. That is the one thing that I was very naughty about not putting on here. Okay, just give me 1 second and I will put them on the screen. Hang on 1 minute. Sorry, guys, let me just get the identities and put them up for you as well. Okay, 2 seconds. There we go. All right, so there we go. Okay, there we go. There are our trig identities as they will appear on your sheet. Okay, so I haven't put the sine rule and the cosine rule and all that kind of stuff on because that's not relevant to what it is that we're doing today. Okay, so if we just have a look at the rules and identities before we get started, what do we call these first 4 up here? What's this called? The ones that I'm highlighting in yellow. There's a name for them. What are they called, Matrix? Okay, so they are called compound angles. Absolutely. So the ones that I've highlighted in yellow are our compound angles. Okay, and we know that when we see sine A plus B, we either expand it or we have to manipulate the right-hand side to get it to look like what it does here, and then we can go back the other way. All right, so we need to be able to be comfortable with expanding and doing the reversal of the expansion. These ones that I'm highlighting in blue over here, what are these called? These are our double angles. There we go. Okay, so these are our double angle formulae. All right, and we know by now that there is only one way that we can write sine 2 alpha, which is as 2 sine alpha. Oh, look at that. There's a mistake here. That's supposed to be cos, isn't it? Sure, interesting. Faheen, I see you've got a question you want to ask. You're welcome to unmute.
Ma'am?
Yes.
Well, can I just ask you to stay on the meeting for a few minutes? There's something I want to discuss to you about my maths results after we finish with the lesson. Will that be fine?
My sweetheart, I have to go and do another lesson online. So if you do want to talk to me, maybe what we can do is talk one day before the lesson actually starts.
Okay.
Okay,
No,
is that
because,
all right with you?
yes. No, it's because it's of
Okay.
my prelim results. That's the problem, because.
Okay.
Mm-hmm.
Right, that's fine. We'll talk about it one day before the class starts. All right, so maybe on Tuesday, just 5 or 10 minutes earlier, and we can talk then.
Okay.
Okay.
Thank you.
No problem. All right, and then we know that there are 3 different ways in which we can write the cosine double angle. All right, so either is cos squared alpha minus sine squared alpha, or 1 minus 2 sine squared alpha, and 2 cos squared alpha minus 1. So these options become super important to us when we are doing general solutions and identities. Then it matters which one we use. Okay, but if we were doing absolutely nothing, Nick, we were just identifying compound angles and double angle formulae, and we're going to get started on the questions now. Okay, so you haven't missed anything. Okay, no stress, welcome. One thing I did note is I copied this from a past paper, but I see they've made a mistake as far as the sine double angle formula is concerned. So sine 2 alpha is 2 sine alpha cos alpha. Okay, so let's just jump straight into the first question. So they want us to simplify this expression to a single trigonometric term. Now, this is where you guys can do a lot to help yourselves as far as trig goes, because you need to make sure that you have studied everything from your grade 11 trig, all your reduction formulae, your negative angles, your co-ratios, etc., etc. So if you've done that, then you will be A for away. Okay, so Diana, I got a different answer to you, but I could be wrong, but let's work through this together. So the first thing that we must notice here is how many terms are there in this expression? I want to start with that. How many terms in the expression? I got close to you, Cleopatra. 4 terms. No, there are not 4 terms, Cleopatra. I'm so sorry. There are 2 terms, absolutely. So remember, in maths, terms are separated by plus and minus signs. So this is the first term. I'm going to highlight it in yellow. That's the first term. The second term is the minus 1. So they're asking us to multiply tan minus x by cos x by sine x minus 180, and then take away 1. All right, so we can see when we look at that there's some manipulation to be done. So the first thing with tan minus x, we would have written that as negative tan x. All right, so we're working in quadrant 4. Then obviously cos x, there's nothing that we can do, so we would just write it as cos x. And what we can do here, as far as the sine x minus 180 is concerned, is we can factorize out that negative. All right, so I'm going to take the negative out, and then that means that I would have 180 minus x in brackets. Okay, from that I need to subtract 1. So a little bit more manipulating to be done. The minute we see tan x, we're going to write tan x as, tan x must be written as sine over cos. Okay, so sine x over cos x. So in this case, we would write it as minus sine x over cos x. There we go. All right, and now we could multiply it with that other cos x that we see there. And now we have to reduce this guy. Okay, so it would normally reduce to a positive because 180 minus x is the second quadrant, but we've got this negative in here. Okay, so this has to reduce to negative sine x. And then again, from that, we're going to take away our 1. So our causes are going to cancel, aren't they? And a negative times a negative is a positive. So that's going to leave us with positive sine squared x minus 1. And then I think probably the easiest thing for us to do is to write 1 as sine squared x plus cos squared x. So we've got sine squared x minus sine squared x plus cos squared x. And when we remove our brackets, we end up with sine squared x minus sine squared x minus cos squared x. So final answer would just be minus cos squared x. Okay, so Cleopatra, I see you've asked a question. Dion, YouTube, I have a negative because 0 is minus than it is in the fourth quadrant. Which one are you talking about, Diana? Where you said, but I have a negative because if 0 is minus, then it is in the fourth quadrant. Which? And then Cleopatra, you're also asking a question. You're saying, can we take... Oh, okay. All right. Sorry. Okay. All right. Cool, Karabo. Cleopatra, can you take 1 back to an identity of sine squared x plus cos squared x? You can. You are allowed to do that. You're allowed to rewrite 1 as sine squared x plus cos squared x. So it's not a problem. So what I wanted to do here is because remember, they want us to go to a single trigonometric term. Okay, so a single trigonometric term. So that means only in terms of sine or cos, not both. All right, so that's why I thought, well, if I use sine squared x plus cos squared x equal to 1, then I'll be able to eliminate my sine squared x term. So that's why I decided to do that. Okay. All right. So if everybody is okay with that, let's go and have a look at the second question, which is also a very, very typical sort of question in this section on trig. So this is called ratio in terms of a letter. And in this case here, they have told us that the cos of 35 degrees is equal to m. So our ratio is m. It's really important that you don't ignore the instructions. So here where it says without using a calculator, if we ignore stuff like that, we are going to come short, all right? So they want us not to use our calculators for these sections. Obviously, if you want to work out what, 215 minus 35 is, just to check that it's 180 or whatever the case is, that's not what they're talking about, okay? But they mean you can't work out the value of cos 215 using your calculator. All right, so the first thing that we notice when we look at cos 215 is that this is not an acute angle. So this is where our reduction formulae becomes super important to us. So we have to use reduction formulae. So we would say that 215 could be obtained by adding 35 to 180. We know that if we write cos 180 plus, that puts us into quadrant 3. Exactly. And we know that cos x is negative in quadrant 3. So this would be written as negative cos 35. This would be the first mark that you would get, would be on this line over here. And the second mark that you would get would be for writing that in terms of m. So in this case, our answer would be equal to negative m. And that's where our second mark would be. Okay, is that making sense to everybody? Yeah, quite right, Itumeleng, negative m. Let's go and have a look at question 5.2.2. Yes, Cassandra, you got a question? You're welcome to unmute and ask.
Hello, ma'am.
Hello, how are you? I think we've lost you, Cassandra.
I'm sorry, ma'am.
There you are.
I wanted to ask regarding the manipulation of sine x minus 180. So, ma'am, if it's sine x minus 180, so I have to put my x outside the square brackets and then write 180 minus x.
Mm-hmm.
And then
So,
if it's sine x plus 180, do I write it as 180 plus x inside my square bracket the way that you did?
Yes, you would. So this thing that I've highlighted in yellow with the green over here, there's actually more than one way to reduce that, or to look at a method for reducing it, which I'm more than happy to sort of go through with you. But the idea behind what I've done here in yellow is this: if you've got sine, and then here we had, let me just get the right thing down, x minus 180. What we're doing is that we're saying the angle is x minus 180. So what I can do is I can turn it around, and I can put the minus 180 first, and I can put the plus x second. Then in the next step down, what I'm doing is I'm rewriting these round brackets as square brackets, and I'm taking a negative out of the bracket. So that's why the 180 has to change sign, and the x has to change sign as well. Now, the rule we are using here, okay, so when we get to this stage over there, what we're actually working with is this. Remember sine minus theta. So it's the sine of a negative angle. It's exactly the same thing. It just, on the one on the left, our angle is 180 minus x. The one on the right, our angle is minus theta, but it's exactly the same thing. So here, how would we reduce this? Well, we would reduce it to minus sine theta, wouldn't we? So it's exactly the same thing over here. Okay, so it's just that there's one extra step in that. The sine of 180 minus x becomes sine x, so this becomes minus sine x, like so. Okay.
Thank you, ma'am.
No problem. Or the other way, if you want to, the other way that you can look at this as well, because remember, this is quadrant 1, 2, 3, and 4. If you've gone x degrees forward, then you're sitting somewhere in the first quadrant. If you now go minus 180, then you swing 180 degrees in the opposite direction. So that means that you would end up in quadrant number 3. So that's why it would reduce to negative sine x. That's the other way of looking at it. Okay.
I think I prefer the first way, ma'am.
Yes, I think I prefer the first way as well. Okay, so yeah, that's the best way. That's the best way to look at it. No problem. Renewa, when you want to add 360, that's normally when you've got something like this. Like, let's say you had sine minus 257 degrees. That's really when you want to be adding 360, okay, to bring it back between 0 and 360. You can add 360 here. It's not going to make any difference. You would just then need to continue reducing until you got to minus sine x. So that would be okay. You could do that. It's not actually a problem. Okay. All right. So let's go back and have a look at the second part. So here we've got the sine of 20. So now we're super confused because we're looking at the sine of 20 and the cos of 35 equals m, and we're thinking to ourselves, what is the connection between these two? How is the sine of 20 degrees related to the cos of 35? What do you think the connection is between these two? Let's just think about our options, right? I mean, is it possible for this to be a compound angle? I mean, could we write it using compound angles? Okay, Karabo, you're saying m over 1. Okay, you're trying to get it to a special angle. Absolutely, I can understand why you do that. And if we have a look at the numbers here, there are no special angles that are going to work for us. Okay, so we can use special angles, and that is a good thing to think about. But in this situation, there is no special angle that's going to work for us. So Diana, you're kind of on the right track there, where you're starting to think about 90. Thinking about 90 is important here. So this is something that comes up from grade 11. And there we go, Spoo. Okay, look at what Spoo, there we go, there we go, there we go, there we go. Okay, Pilo. All right, it would be cos 70. Well done, Spoo. You also said the same thing. Okay. Of course, Diana, go ahead and unmute.
Okay, ma'am, can you hear me?
I can hear you.
What if you take sin 20 and you say 90 plus 20, then that gives you 110, but then you can divide 110 to get 55, and 55 is the other angle in the triangle, and then it becomes 2 times 55, which will equal 110. Then that becomes also one of those special double or compound angles. I can't remember which one.
Okay, absolutely. So quite right, quite right. What you would need to do though is that before you can do that, you would have to show that 55 would be the other angle in the triangle. So it would mean you would have to draw a diagram. So what
Mama did.
Yeah. So as long as you drew a diagram and the 55 was on the diagram, then that would be absolutely fine. Okay, so what you're suggesting there is a lovely alternative method. It would just take you a few extra steps, Diana, but there's nothing wrong with what you were thinking.
Okay, ma'am.
No problem.
Just can you also do that one? Because that took me a while.
I'm gonna do it now. Absolutely. So I think this is the easiest way to do this particular question, is to write sine 20 as cos 70, and then of course we know that 70 is 2 times 35. All right. So now we can go and use one of our double angle formulae. So one of the angles from up here. So whether we use the first, the second, or the third, I don't think it really matters. What we want is it in terms of m. So you know what, since we've got cos of 35 is equal to m, I'm going to do this, and I'm going to choose 2 cos squared 35 minus 1, and then I'm going to replace my cos squared 35 with my m. So it'll end up being 2m squared minus 1, and that would be our answer. Okay, yes, we would use co-ratios for this question into causal. So they're very, very important, our co-ratios. Okay, so remember, if you've got the sine of 10, you can write that as the cos of 80, okay, etc., etc. Or if you have the sine of 1, you can write that as the cos of 89. So yeah, that comes up a lot in normal working. It comes up in problem solving. So yes, very important that you are aware of your co-functions. So yes, make sure that you've learned those. How did I get the minus 1? Okay, so I'm using the, Joshua, I'm using the formula. Okay, so here, this is where it comes from. I'm using my double angle. Hang on, let me just go to my thing there. So 2 cos squared alpha minus 1. Okay, so that is my cosine double angle formula. Okay, that's where the minus 1 came from. Okay. All right, well, if we're all good to go, then I would like to proceed with the next question. I just want to do a check-in with you guys. How are you feeling? Is this making sense so far? Are you okay? Some emojis, just to give me an idea of how this is going down. Cool. All right. Oh, that's nice. Thanks. Awesome, everybody. Okay, so Diana, your alternative solution. All right, let's see. Okay, you sure? Okay. Okay. Let's go on and talk about the general solution. So now, again, remember, we want to have our formulae right next to us so that we can refer to them quickly and easily. And we see this. So cos 4x, cos x plus sine x, sine 4x. So what does that look like? What I'm going to do actually here is I'm going to copy that and I'm going to paste it over there so that we've got it here as well. What does it look like? Remember, there was an error here that needed to be. Okay, yeah, absolutely. It's a compound angle. definitely a compound angle. So we can see here, cos, sine, sine. So we know that it has to be a cos compound angle. And we know that cos does not keep its sign. So in other words, if I've got cos A plus B, then over here I've got a minus, and I've got cos A minus B, then over there I've got a plus. So what I can do now, because what I have on the left-hand side over here, it looks identical to what I have on the right-hand side. So that means that I can do the reversal of the expansion. So I can write cos 4x cos x plus sine x sine 4x equals negative 0,7. I can write that as cos 4x minus x, and that will leave me negative 0,7. So essentially what I've got here is cos 3x equals negative 0,7. Okay, good. Well done, everybody. Good. Okay. So now that I've got to the situation, I mean, this is what I always want with the general solution. I always want to get to a situation where I'm saying cos x equals, or sine x equals, or tan x equals. All right, and once I've got there, then it means that I'm ready. You are allowed to simplify. You must simplify, Karaba. Often with general solutions, they can be so creative. So they can make you do ones with factorizing. They can bring in compound angles. They can bring in double angles. There's really so many different ways in which they can ask this question. So yes, you do need to be aware of all of those things and thinking of all of them before you get started. Okay, so yes, we would have to reduce it to this so that we're now able to find our reference angle, or as we teach at my school, we teach the boys to find a positive acute angle, but it's exactly the same thing as a reference angle. So if you guys call it a reference angle, it means exactly the same thing. The only thing that we don't do, right, is we don't use signs, and by signs I mean plus and minus signs, when we calculate our reference angle. Our reference angle is always going to be positive. So on our calculators, we would go shift cos, and we would pop in positive 0.7, and that would give us a reference angle, or PAA, let me just change the pen back, of 45,57 degrees. Okay, are you guys getting the same thing? That's it. Perfect. So once we have this reference angle, now we are ready to start putting our general solution together. So what is the negative used for? Fahim, you've got your hand up. You're welcome to unmute and ask.
Ma'am, I didn't get this answer to 45.57. I got 76,50. That's what I got.
So, all right. So Fahim, maybe your calculator is not set on degrees. So look at what your calculator, have you got a Casio?
Yes, ma'am, I do.
Okay. All right. So what I want you to do is this. I want you to press Shift 9,
Shift
3.
Oh, I see. Oh, okay.
Equals AC. Okay. So you're going to press Shift 9, 3 equals AC.
Yes.
That will reset your calculator. And now I want you to try it again. Remember, you're going to go Shift cos and then pop in the 0.7.
Oh, just 0.7. I put 0.7 over 3. Oh, okay. Yeah, I got it.
No, you're not over 3, not over 3, because your 3 is part of your angle. The 0.7 is your ratio.
Okay. Thank you, teacher.
No problem. Anytime. Anytime. Okay, so now we've got our reference angle. Now we want to go and have a look at this, and we're going to, what I was saying to you guys before, what do we use the negative for? So this negative that I've highlighted here in yellow, this guy here, what am I using that for? For quadrants. Quite right, Karabo. Okay, so negative and positive is for quadrants. Okay, so it tells me which quadrants exactly to which quadrants I'm supposed to be working in. So now the question is, in which two quadrants, correct, Nick, in which two quadrants is cos x negative? It's negative in quadrants 2 and 3. Okay, so that's where I'm going to do my solutions. Okay, not 3 and 4, Cleopatra, 2 and 3. Remember, cos x is positive in quadrant 4. Okay, maybe it was just a little typo. 2 and 3, that's it. Yes, 100%. Okay, good stuff. Now, this is where you end up using the 3x, Fahim, okay, because your angle is 3x. So here we're going to write our angle, which is 3x, is equal to 9 quadrant number 2. We're going to do 180 minus our reference angle, or PAA. And because we're talking about the cosine function, it's going to be plus multiples, that's a k, times 360. Okay, and then remember, k is always an element of the integers. So now we would end up taking the 180 and minusing the 45.57. Let me just do that. And that leaves us with 134,43 plus k times 360. And now this is when you divide through by 3, because remember, we want to solve for x. Okay, good, well done. All right, so now we're going to divide through by 3. And that is going to give us our first answer. I don't know about you guys, but I'm getting 44,81 plus k times, don't forget this term over here also has to be divided by 3. So this will become 120. Okay, so just be careful about that as well. Okay, you're getting that. Lovely, Spoo. Nice. Vanolo, go for it. You're welcome to unmute and ask.
Yes, ma'am, I wanted to ask about getting the 45.57 degrees, because in my calculator.
Okay, are you not getting the
a
same
problem.
answer that we're getting? Are you not getting the same
Yes,
answer,
ma'am, I'm
Vanolo?
not.
Oh, okay. All right. So what I want you to do is this, okay? On your calculator, have you got a Casio?
Ma'am?
Have you got a Casio calculator, Vanolo?
Yes, ma'am.
Is it a Casio? Okay. So I want you to do the same thing that I was saying to Faheen, okay? I want you to press Shift 9,
Yes.
3
Yes.
equals AC.
Okay.
Okay, and that will clear your calculator. So if you were accidentally on radians or something else, then it will set it back to degrees. Okay.
Ma'am?
Yes, Banolo?
You're saying after I've pressed the equals?
Yes. Then you press AC.
Yes, I've done that.
The AC button.
Yes, I've done that, ma'am.
Have you done that now?
Yes, I'm done.
Okay. All right. So now we're going to try it again. Okay, Banolo. What you're going to do is you're going to press Shift.
Yes.
Cos. And then you're going to put in 0.7, positive 0.7.
I can't hear you properly.
Okay, so you're going to...
3.
No, not 3. Shift, cos,
yes.
And then 0.7. So this is what you're putting in. I'll write it on the screen for you. So you're going to press Shift, cos.
Yes,
okay, and then it's going to look like this on your calculator. And then you're going to put in 0.7 and you're going to press equals. What do you get?
Thank you, Mama. Got it.
There we go. Okay, Banolo, I'm glad we were able to help you sort that out. This app keeps kicking you out. Really, Nick? I'll have to see what's going on there. So yes, you must divide the So the 180 Carabo, what happens is that you've taken the 45.57 away from the 180, and now you've got 3 terms. All right, so here's your first term, which is your 3x. This is your second term, and this is your third term. All 3 terms are divided by 3 in this particular case. Right, so the last thing that we need to do is just go and finish this off because we didn't do our solution in the third quadrant. But I see who had a hand up? Cassandra. Go for it, Cassandra. You're welcome to unmute. Oh, excuse me.
I've always had a problem with writing the plus k times 360 k as an element of z. Ma'am, are there different parts whereby if my reference angle is a negative or a positive, that, like, I don't understand the part, ma'am, where we say x equals to 180 minus 45,57.
Okay, all right. So what we are doing here, so this first bit over here, let me just get blue. This is the angle that you are solving for. So that comes from here. All right. Then you look at the sign of your ratio. Okay, so when I say the sign of your ratio, I mean the sign. Okay, so plus or minus. And that is what you use to decide which quadrants you're going to work in. So in this case, we are talking about the cos of an angle. So if we draw ourselves a quick little cast diagram like that, we know that cos is positive in quadrants 1 and 4. So it's negative in quadrants 2 and 3. What is the reduction formula for quadrant 2? It is 180 minus. That's where this bit comes from. So this 180 minus over here is because we are working in the second quadrant. The 180 plus, which I've now got on the board, so that's this bit over here, the 180 plus, that comes from here, from quadrant 3. So when we are in quadrant 3, we are using the reduction formula 180 plus. Okay, if you were working in quadrant number 4, Cassandra, then you would use 360 minus. Okay, so that's how you know what it is that you're supposed to be writing in the first line. So it's your angle equals, then what quadrant are you in? Use the appropriate reduction formula, right, for that particular quadrant. And then you need to add multiples of 360. All right, so adding and subtracting multiples of 360 is what allows you to find solutions anywhere along the x-axis, okay, for this particular question, right? Because the cos graph repeats itself every 360 degrees. So every 360 degrees, you would find that there would be a solution to this particular problem. Okay, and then of course, when we end up collecting like terms and dividing through by 3, we actually get x equals 44.81 plus k times 120. Does that make a little bit more sense? Pleasure, Cassandra. Okay, so this is why I'm writing the 3x 180 plus. Okay, so then you would take, because we're working in quadrant 3 now, so we would take our 180, we would add our 45.57 to it. I don't know about you guys, but I'm getting 3x is equal to, I'm getting 225,57. Plus k times 360, k is an element of the integers. And now, like with the previous question, because it's 3x over here, I have to divide everything by 3. Okay, so I'm going to divide the 3x term by 3. I'm going to divide that by 3. That's going to give us 75,19. And then I need to divide this by 3 as well. So that would be k times 120. K is an element of the integers. Okay, good stuff. Well done. Yes, Itumeleng. That's exactly what I got. De Corso, you also got the same thing. Oh, Nick, maybe try logging out and logging back in again, Nick. I don't know why you're having issues with this tonight. That's so frustrating. I'm so sorry. Okay, so is everybody good with that? Is that making sense? Can I move on to the next question? Yes, all right. Good, thanks Ntebogang, thanks Ntokozo, Ratidzai, Itumeleng, good, thank you Cassandra, thank you Sandisiwe. Okay, so the next thing that they wanted us to do is they wanted us to prove this horrible identity, okay? So often we would look at questions like that and we would be like, that is just nasty. But hopefully we can work through it together and then you guys can see that it's not really as bad as you think. Now, what I'm going to do is I just want to move that out the way because I never, ever, ever leave enough space. And I'm just going to copy this again so that we've got it over here. All right. Obviously, we've worked through all the questions. It's only the identity that we now want to prove. Okay, so we're on 5.4. Oh, the other thing, let's just bring this down for ourselves. Is let's just bring our identities with us, and then we've got them close to hand as well. So I'll just shove them there on the side. Okay, so if we have a look at our identity, on the left-hand side in the numerator is this whole long sine 4x cos 2x minus 2 cos 4x sine x cos x, which is really quite intimidating, all over tan 2x. And on the right-hand side, we've got cos squared x minus sine squared x. So we can see here what they've given us there on the right. That's this. So we know that we need to get cos 2x as an answer. That's where we're headed. We want to get cos 2x as an answer. So, and if we do, when we do, that means that we will be able to write cos 2x as cos squared x minus sine squared x. So that's where we're headed with this particular problem. If we now go back and focus on the left-hand side, is there anything there that we could probably use or look at our formula sheet and say, okay, well, I see something here that might be the same. What does it look like when it goes sine 4x cos 2x? I know the rest of it isn't exactly the same, but what does it kind of look like to you? Because here you've got a sine 4x and a cos 2x. Cassandra, go for it.
Ma'am, I think it looks like a compound angle cos, it says sine 4x cos 2x minus cos 4x sine x cos x. And if we say 2 sine x cos x, that's sine 2x. So we can easily change that into our compound angle.
Absolutely, absolutely. That's really well spotted. So that's exactly what's going on here. Look what they've done here, guys. That 2 is this 2 over here. And this sine x over there is this sine x over here. And remember, this was wrong. This was supposed to be cos x. So let's just change that back to cos. So this cos x over here is that cos x over there. Well, what they've done is that they've been mean to us. They've split the 2 away from the sine x and the cos x. But it doesn't matter that they've done that because the order in which we multiply does not matter. Okay, so they've just made this question a little bit more difficult by writing the 2 first and then the sine x cos x later on. All right, but if we can recognize that on our formula sheet, then it's really not so bad. So left-hand side equals, and you're quite right, this does look like a compound angle. So sine 4x cos 2x, and then over here we're going to write minus cos 4x, and then at the back here we can write this as 2 sine x cos x. So all I've done is I've moved the 2 from here to in front of there, okay? So that it ends up looking like this. Remember, this has to go over tan 2x. Tan 2x can be written as sine 2x over cos 2x. Okay, and just be very careful when you write things like that, because it's very easy to write sine 2x like that, and what we're actually writing is sine squared x and not sine 2x. So yeah, just be very careful in terms of how you set things out, etc., etc. Okay, so now what I'm going to do is I'm first going to rewrite, just get down there, my 2 sine x cos x, I'm going to rewrite that as sine 2x. Okay, so I'm also doing the reversal of the expansion. And now we've got all of that over sine 2x over cos 2x. As Cassandra and a few of you had pointed out so correctly, what we've got here is a compound angle. Okay, so sine cos, cos sine, it has to be one of our sine compound angles. Okay, sine keeps its sine, so it's got to be this one over here. All right, now Cleopatra, I see you've got your hand up. You're welcome to unmute and talk.
I wanted to ask, when you move the -2 to the other side, is not gonna affect the whole thing?
No, and the reason why it won't affect the whole thing, and this is why it's important for us to know how many terms there are in expression, because what you have here, let me just get the eraser and just rub, oh, wrong thing, just rub that out. This is one term.
Yeah.
It's one term. Remember, terms are separated by pluses and minuses. So all I've done is I've just reordered the factors that make up this term. So in other words, if I do this, if I say 2 times 1 times 3, and then you come along, Cleopatra, and say 3 times 2 times 1, we're both still getting an answer of 6, aren't we? So the order of your factors does not matter.
Okay, ma'am, thank you.
Okay, all right. So it's very important that you guys can see that. Now that we can identify what we have here in the numerator on our formula sheet, we are now ready to do the reversal of the expansion. So this would be sine 4x minus 2x. So we would use our formula and write sine 4x minus 2x. And that's it, lovely. And here when we've got this divide line, so this divide line over here, I'm going to change it to a times, and then I'm going to flip the fraction that follows. So I'm going to put cos 2x at the top, and I'm going to put sine 2x down at the bottom. Okay, so I'm going tip and times here. So this gives us sine 2x times cos 2x over sine 2x. And now I can cancel those two with one another, and look at that. That's what we said we wanted. Do you remember at the beginning? We said that we wanted an answer of cos 2x, because if we get that, we can write cos 2x as cos squared x, horrible x, minus sine squared x. Okay, that's it. Quite right. What's up, Ntukozo? Don't be sorry. It's fine. You're welcome to ask. Sure, go for it. Do you want to unmute, Ntukozo? If it's easier for you.
Good evening, ma'am. Good evening, ma'am.
Good evening.
I just have one question.
Sure.
How did you get the sine? Oh, is it a compound angle?
Yes, it's a compound angle.
Oh, okay.
Yes, so
okay.
sine 4x minus 2x, that's a compound angle. That's the reversal of the expansion.
Oh, thank you, ma'am.
Okay, no problem. All right, Itumeleng, I see you've also got a question. So Itumeleng, remember when we divide, the opposite of divide is time. So in other words, it goes back to like something like this. So if you've got 3/7 divided by 14/9, then remember we would keep the 3/7 as it is, and then we would do tip and times. So we would change the divide to a times, we put the 9 at the top, and we'd put the 14 down at the bottom. Okay, and then we could cancel or multiply or do whatever. So that's exactly the same thing over here. You've changed this divide into a times, and you flip the fraction that follows. Okay, that's quite right. Okay, so when we divide with fractions, we tip and times. Okay, so I see there's a couple more hands up. Let's see who, hang on a seckie. Bonolo, go for it.
Ma'am, I wanted to ask about the sin 4x minus 2x. How did you get there, ma'am?
Okay, so the sine 4x minus 2x, this is your compound angle. All right, so in other words, what I'm doing is let's just bring this guy down here, okay? If you have a look here, Bonolo, at what's on the right-hand side, that's exactly what you've got in the numerator over here. Can you see that? When you compare them, it's exactly the same thing. So if we see what we have on the right-hand side, it allows us to go back and go and do this. And that's exactly what I was doing here. Okay, so I was going from the expansion to the reversal of the expansion. Okay, so in other words, I'm applying this. So like here you can see sine alpha minus beta. I've gone sine 4x minus 2x. Does that make more sense, Bonolo? Yes, exactly. Does that make sense, Cleopatra? Okay, so yes, now you're doing the reversal. Okay, because you're trying to condense it down. You're trying to, yes, you're trying to simplify, essentially. Okay, you understand now. Oh, good. Okay. All right, awesome. How much time do we have left? Only 7 minutes. Okay, so it never ever enough time for us, is there? All right, so there's this question here as well, which I had wanted to do with you. I don't know how far we'll get. Sorry, was somebody
only
talking?
have 2 minutes before.
Oh, do we only
go.
have 2 minutes? Oh, okay,
Yeah.
before I have to go. Absolutely. Okay. So do you want to do the poll?
Yeah, the quiz. We have a quiz today.
Oh, of course, it's the quiz today. Sorry. It's because I missed on Tuesday's lesson. So that's why I'm thinking poll, not quiz.
Ma'am,
Yes.
I had a question.
Sorry, Ntebogang, you did. I beg your pardon. Go for it. What did you want to ask, Ntebogang?
Ma'am, so where did the 4x go?
Which
I see
4x?
now we have sine 2x times cos 2x over sine 2x, but where did the 4x go?
Okay, so here, these are like terms in Ntebogang. 4x minus 2x is 2x.
Oh.
Okay, it's like terms.
Thank you.
Okay, no problem at all. Yes, so we subtracted. Quite right, Cleopatra.